Okay, so now it's time to deal with the multiplication rule for n independent events. Now the multiplication rule is how we handle and. So back in section 5.2, the addition rule is how we deal with or, the word or. So when I want the probability of E or F, I want the probability of E plus the probability of F minus the probability of E and F. Okay, so that's how we deal with the or one. But the and one, right? How do we find the probability of E and F? That's with this multiplication rule when I get to it. Hold on. There it is. All right. It says what you do is if they're independent, of course, this is only going to work if they're independent. If they're independent, then the probability of E and F and G is just the probability of E times the probability of F times the probability of G and so on. Okay. So let's start here. So you roll 3 fair 6-sided dice. Are the die tosses independent? Well, yes, right? Rolling one die has no effect. I can't remember if it's this. Yes, effect on the other dice, right? And vice versa. So what's the probability of rolling 3 ones? Okay, so what I really want is, let me make this a little bit larger. Here. The probability of 1 on the first die, 1 on the second die, 1 on the third die. Okay, so that's the probability of 1 on first. Sounds like the old Laurel and Hardy. Who's on first? What's on second? I don't know. Third base. All right, 1 on second. 1 on third. Okay, but we said they were independent. So all we really need is the probability of rolling a 1 on the first, which is 1/6, times the probability of rolling 1 on the second, which is 1/6, times the probability of rolling 1 on the third, which is 1/6. So that's a 6 times a 6 times a 6, which is 1 over 216. Ta-da. All right, next. Suppose 3 random people, totally unrelated, walk in to donate blood. What's the probability that all 3 of them are O negatives? All right, well, first of all, let me just mention, why am I dealing with the unrelated thing? So let's note, right? Random, unrelated people is to ensure, independence. I don't know if that's an insure or an insure, but one way or the other. Okay, so then the probability that all 3 are O negative is equal to the probability the first one's O negative times the probability the second one's O negative times the probability the third one's negative. So it's probability of hold on, I'm going to pause. I'll be right back. Right, so there we go. It's the probability of O negative on the first times O negative on the second times O negative on the third, which would be equal to 0.1048 times itself 3 times. So when you do that, that's the thing is finding it to the third power. Oops, wrong button. There we go. So here, maybe that'll be, it's this times this times this, right? Which is equal to that to the third. And that's how we're going to find it with Excel. All right, so to find it with Excel, we just need to type equals 0.1048 to the third. That's the caret button that's above your 6. You have to do Shift 6. There you go, 0.001151. Cool, done with that. Next, notice when they're independent, things are easy, right? It's when they're not independent that we're going to have more difficulties. All right. What's the probability that you lose your turn 2 times in a row by spinning bankrupt or lose a turn? Bear with me. I just typed that up for a second. So we found the probability of lose turn or bankrupt. It's 3 out of 24. We found it before. And if you want to do it twice in a row, it'd be 3 out of 24 times 3 out of 24, which would be, well, whatever 3 out of 24 squared is. Hold on. There it is in Excel. Type it in parentheses, equals 3 out of 24 squared.